So yesterday we looked at our basic functions, right, that are trig. And even though I'm going to write sine right now, it applies to cosine as well. But they had four parameters. A, B. Right. C, and D. So we looked at just two of them yesterday. How is this? So on Monday, this. Today we're going to look at just what C does to the graph. Okay. And then we're going to add in a little later this one as well. I'll put later. All right. And it's actually, this last one is one of the more basic ones anyway. So, but what this is just a generic way of looking at graphing. So if I bring this Desmos into here, you can see that if, turn on the sign here, click in it, and you change the A value, which is the amplitude, changes how tall it goes. So positive opens up, and then just like any function, a negative will invert it, up and down. Right? So that's what the value of A did. Okay. Then we have this new B value. And this is what gave us how many times or how many cycles per 2 pi. So within 2 pi, you can see that this sine wave goes up and down. So it does one full cycle by the time you get to 2 pi. And if I change this to 2, right here, now it does. Now it does it. Wait a minute. There we go. 1, 2, 3. That didn't work. Oh, changed the wrong one. I'll leave it there. Change this to 2. There it goes. Now it does 2 cycles. Once here and then another one here. And if I change this to 4, same thing. And now it's going to do 4 cycles within 2 pi. So you can see up, down once, up, down twice, up, down 3, up, down 4. So this number B tells us how many cycles the graph will go through, whether it's sine or cosine. Right? That still goes down, up once, down, up twice, down, up 3 times, down, up 4 times. So it always gives you how many cycles, whether it's cosine or sine. And then we calculate a different value called the period that says how long each cycle is. So like from here, each cycle would be pi over 2 because that's when the next cycle starts. So every pi over 2, there's a new cycle, and it goes 4 times. So those two values got to go hand in hand. All right, now the next value is going to be C today. That's just going to be a horizontal translation. You'll notice if I change it to a positive, it appears to be moving left. Right? The graph appears to move left, which is kind of counterintuitive. And if I move it to the left, the graph appears to move to the right. So just keep that in mind as we go forward. And I'll attach this on your homework assignment on Classroom, so you can go through and you can check every single graph. So all your graphs should be 100% correct, because after you did them all, you went through here, or you went to Desmos, typed them in, and everything is as it appears on Desmos appears on your paper. So if there's any mistakes, you found out what they were, and maybe didn't understand it, but still corrected it, and then asked hopefully when you came in, hey, how come this graph does this? How come, it didn't do that? I thought it would have done this, but it did this instead. So you want to keep asking those questions until you make sure you understand how it works, so you don't need decimals any longer. Yeah.
I just want to ask, what happens when your B value is negative?
So B value is negative. We're going to look at that anyway. So here's like a -2, right? There's -2, which if you take +2, and you change amplitude to -2, you'll see it's the exact same thing. So yeah, there's a little proof we're going to do very soon here that shows that. And that's right down here, number 12 from yesterday's assignment. So we'll look at that. All right, so first thing, let's graph the base functions here. So let's go through and just make sure you can graph these basic functions, both sine and cosine. And it's important that these are all equally spaced. So as you're doing it, I advise you to go to the very end here, right, and mark 2 pi And then to get pi, go to the middle of 0 and 2 pi. That will be pi. So you take the midpoint again. And we're just estimating it. And then you go to the middle of 0 and pi, and that would be half of pi, or pi over 2. Then you go to the middle of pi and 2 pi, and between 1 and 2 would be 1.5, and that's what 3 over 2 has always been. That's 1.5, right? So it's like half, 1, 1.5, 2. Just kind of by a half pi each time. And then we'll just do sine up here is equal to 1, and then, y is equal to 1 and negative 1, right there. And do that on both. Go do the next one on your own. Alright. And let's graph each. But as you're graphing it, I don't want you to do it by memory, but I want to make sure it makes sense, right? So it's great to memorize stuff, but I always want you to remember that, well, this is 0 right here, like 0 radians. So what is the sine at 0 radians, right? It's 0. The height, right, or the rise is 0 at 0. And then what is the rise at pi over 2? That's 1. The rise at pi, back to 0. The rise at 3 pi over 2 is negative 1. And 2 pi, which is the same as 0, back to 0. So we should make sure we understand why this graph is shaped this way. It's just made up of plotting all the rises of each of these radians. All 5 of them, including 0. If you include 0, it's 5. Same thing for cosine, but we're just doing the run, right? So what is the run at 0 radians? Positive 1. The run at pi over 2 is just 0. The run at pi is negative 1. And the run at 3 pi over 2 is back to 0. And the run at pi over 2 pi is back to 1. So that's why the cosine looks like this. So there is our sine and cosine, our base graphs. Now we can use that to help us graph anything else when we start changing the numbers. So for here, this is like something from your homework. Look at the amplitude, and we have 4 right there. So that informs our graph that we should go up to positive 4 and negative 4. So amplitude helps us choose our scale. And then we have our b value right here, 1/4. So let's go to our cosine graph, since this is cosine, and so we can see exactly what this means. This number tells us I want to graph this much of the cosine graph over pi over 2. So I'm going to take up the entire pi over 2 for this much of the cosine graph. So 1/4 of the cosine graph would be right here. Like that. So this part where it's just going down from 1 down to 0, I want to graph that, but instead of ending at pi over 2, I want to end at 2 pi. So this tells us graph 1/4 of the cosine graph, but take up the entire 2 pi. And if you see this right here, it'll let you know, like, okay, I'm going to start at 1, I'm going to end at 0, right? So that's why we need to have that. And then when I go over here, I'm going to start at, instead of 4, I'm going to start at 4 here, but I'm going to end at 0. I'm going to end right here. And all I'm doing is just going down. Take off the shade. Make sure it's nice smooth. Something like that. So this 1/4 value right here means a fourth of the graph fitted to 2 pi. And then we had the last value, which was to find the period, but you just take 2 pi and divide by whatever the b value is, 1/4. In this case, that gives us 8 pi. And that this value represents how long it takes to do a complete cycle. So this is just a quarter of the graph, right? And it took up 2 pi. So there's 3 other quarters of the graph that will make up the 8 total pi. So if I go over here, you can see, so this right here would be another 2 pi. So this was 2 pi. This would be another 2 pi to graph the second quarter. The third quarter of the graph would be another 2 pi. And the fourth quarter of the graph, right, that would be another 2 pi. And that is why the period comes out to be 8 pi. So just want to make sure we visually understand all this and why these values are what they are. The thing we don't want to do is memorize, okay, this is the formula, and then I get that answer. Okay, what does that answer mean? I don't know, but I got it. I'm done. That's the last thing you want to do, because we have to make sure and understand it. So when we're graphing, if there's a mistake, we'll be able to spot it, right? If we're doing it from memory, maybe not so much you will catch any mistakes. All right, so, and then going back to the earlier question, one of the problems from the homework, this always comes up, of how do you graph this, right? So there's a couple ways of looking at it. When you have a negative on the inside, and I already showed you a little bit earlier, that it turns out to be inverted, kind of like a negative amplitude. So the way I'm going to prove that is true, right, is I'm going to use one of the formulas from last section. So I'm going to write negative x as 0 minus x. That's the same thing. And then I can use the formula sine of 0 cosine of x. That would be the formula, minus cosine of 0 and sine of x. Okay. And then each of these that have an actual number, I can find out what that value is, of course. The part that doesn't have a number, the variables just drop down to the next step. So we can actually use these to help us solve some of these problems. So sine of 0, the rise of 0 is 0. The run of 0 is 1. Of course, this will cancel out. 0 times anything is 0. Minus 1 sine, we can just get negative sine x. So it turns out that these are indeed the exact same thing. That if we have a negative in front of the b value, that's the same as if we just pop that negative out and have the amplitude negative instead of the b negative. So anytime you see a negative b, the takeaway from this is that just take that negative out, right? Do this graph like normal, but then invert it at the last step. Okay. So this will look like an inverted sine graph. Let's make this -1, it's +1. So that would go down here, up here, up here, and down here. There we go. And this will come up over and over and over with what we're about to do. The fact that we can use these formulas to simplify. So, including right down here. You can see we have a format here. Our next one has sine of x minus pi. So we can easily use one of the formulas to give us, what this is equivalent to in a simplified version. So, as you saw before on the Desmos, these are just going to be horizontal translations, also known as a phase shift. Okay. And we're going to do the first steps the same that we always do. So we're going to find the amplitude, right? That's still 1. The b value is still 1. The period is 2 pi divided by 1, which is 2 pi. And we have this new part, which is the phase shift. Now this is how far left or right you're going to move the graph. So going back here, the c value is just going to move the graph left or right. Okay? That's what it will do. And this will tell you by how much. So the way to figure out the phase shift, it says right here, set the bx plus c, aka the part in parentheses, right here, set that equal to 0. So I'm going to take that, say x minus pi equals 0, therefore x equals pi. So this tells us I'm going to shift pi to the right. Pi units to the right. Alright, so the way to do this is actually you're going to graph it without this, and then do another graph where you move everything over. Okay, so the first one, do it very lightly in pencil because we're going to do another one afterwards and erase this first one. All right, but the best way to do this is to do lightly. I'm going to use a dash for myself here. Just go ahead and graph y equals sine of x. So the same y equals sine of x we already know. It's going to be a shift of 1. It's called amplitude of 1. We have here, up to here, down to here, here, up to here. And you're doing this very lightly in pencil on yours. So we're going to erase it. Yeah, just move everything over pi. So in this case, from here to here, you can see pi is 1, 2, 3, 4. Right, so we're moving it this way to the right. So you think when you see this, you want to decode this as okay, that's 4 boxes. 4 boxes. 1, 2, 3, 4. So every single point just moves over 4. 1, 2, 3, 4. And this one as well. We'll move over 4. 1, 2, 3, 4. You don't want to graph anything off the grid though. Like right here, it goes 1, 2. Never go like, okay, I'll just make, I'll make my own, and don't do that. Stay on the graph. So if you go off the graph, say, well, that part I'm not going to graph. But everything else here, we moved over. That one, and this one as well. They're all moving over. So instead, I'm going to be going to a different color. It's green. I'm going to be going up this way and coming back down. And I can finish the graph because since this is up, I know behind it will be a down. So from here to here, we'd have this part. If we had the negative part, this would have been moved over from the negative side. So there's our new graph. And then the last step is to go ahead and erase the original one that we started with, the one before we translated it. So you go through and say, okay, don't need that, don't need that. Anything that's not of your new graph, you get rid of that. So your answer should have one graph, right? Left over. Now, what does this look like? What graph does this actually look like? What is the equation of this graph, based upon earlier? Same thing here, right? Turns out it's the same graph as negative sine, right? So if we take off, we look at this and we went through and did the entire formula, right? We could actually prove that. We could say, okay, cosine of x and cosine of pi. No, sine of x, I guess it would be right. Yeah. Sine of x. Cosine of pi. Minus cosine of x. Sine of pi. Figure out these two values. Cosine of pi is -1. And sine of pi, of course, is 0. And once again, the cosine times 0 cancels out, and we're left with sine times -1, which, voila, is negative sine. So now, before when you're doing these in your homework, you're just, okay, I plug these in, I get an answer, and okay, I guess these are equal. But now you can actually see, yeah, the sine of x with a pi phase shift is the same thing as just a sine of x that's inverted with an amplitude of -1. So that's how you want to interpret this, is that a pi phase shift equals a -1 amplitude. So pi phase shift, by shifting it over pi, it's the same as just inverting the original function, right? So it has a way more, practical meaning and graphical meaning when you look at it this way, rather than we just used the formula and it's simplified. It went from sine of pi, x minus pi, now it just equals something a little smaller, which is, opposite of sine. But, now we have a reason why it makes sense. All right, so that's the process. Draw a sketch without the phase shift, and then you're going to count, like if this is pi, we got pi right here. You count that many squares, how long it takes to get there, and do that for each, and then go back and erase the original. All right, so let's do one more. You guys can get started. All right, so we've got our amplitude, 3. So we can mark our y-axis up to 3 and -3. We have our b value, which is 1/2. That makes our period. Pi over 2, always 2 pi divided by the b value. It's going to equal 4 pi. And lastly, set the parentheses equal to 0 and solve. So we're going to take this, set that equal to 0. 1/2 x plus pi over 2 equals 0. So we get 1/2 x equals negative pi over 2. Right? Multiply both sides by 2, so we just get negative pi. So our shift is going to be pi, once again, but this time negative to the left. So we'll go the other direction, which is totally fine. So base function, don't worry about this. Pi over 2 shift yet. Don't worry about that part. Just graph the 3 1/2. Alright, so this is cosine, so it helps to go back over here if you need to. Alright, so this time we're going to graph half of the cosine graph. So from here to here to here. So we're graphing this half, but stretching it out to 2 pi. So we're going to start at 3 and end at -3. So start at 3 and down here at 2 pi at -3. Which of course means right in the middle we have to go through 0. So we can mark pi at 0. And draw a curve. Even though this looks like this, you could draw a nice straight line. You don't want to draw a straight line, you want to draw a curve. So and just for safe measure, since we know we're shifting, let's do the other side, which would be symmetrical. So if we have the right hand side, we can just match the symmetry, and it'll be this identical on the left. And finally, let's do the pi translation to the left. So pi on here is 4 boxes once again. So each of these we just move 4 to the left. So right here to the left, right here to the left, to the left, and draw this nice smooth curve. Something like that. There we go. And we could probably continue it as well. We know it's going to go back up. Right there. Right, there we go. There's our graph. If we need to, always go back here. Not if we need to. We should. Go back here. Go back to Desmos. Hey, this is a cosine graph, so you can turn off sine, turn on cosine. A value is 3. Dial this up to 3, positive. Then we have b equals 1/2. So drop this down to 1/2, 0.5. And then change the, here it's going to be, what, pi to the left. So or other way. Yeah. And then our graph should match. Yeah. Cool. All right. So that being said, let me pass out your homework, and then you can get started.